సరే సార్.
Yeah, children. So we are studying. Now we are going to discuss about metallurgy, extraction. Okay. So seriously speaking, what is metallurgy? Steps involved in extraction of metals is called metallurgy. Steps involved in extraction of metals is called metallurgy. Okay. See, this is earth crust. Whatever you extract from earth crust, that is called as mineral. What is mineral? Any substance. What is mineral? Any substance extracted from earth's crust. Any substance extracted from earth's crust is called mineral. Any substance extracted from earth's crust is called mineral. Okay. Now, what is ore? What is ore? Ore is also mineral. Ore is also mineral. Ore is also mineral from which metal can be extracted profitably. Metal can be extracted profitably. Metal can be extracted profitably. See, whatever you take out from the earth is a mineral only. From that mineral, if you are getting a metal, it is called ore. If not, it is just a metal. Anything you dig the earth and get it, that is called mineral. But from that mineral, if you are getting metal, then that is called ore. That mineral is called an ore. All ores are minerals, but all minerals are not ores. All ores are minerals, but all minerals are not ores. If metal is coming only, then that is called mineral. Yeah, define metallurgy, Harika. Metallurgy means what are the metallurgy? Steps.
Steps involved in extraction of minerals is called metallurgy.
Metal. Steps involved in extraction of metals is called metallurgy. What is metal? Mineral? Any substance
Any
which is
substance extracted from Earth's
Earth's crust
crust.
is called metal. Anything. What is ore? Define ore.
A mineral which a metal can be extracted
From
profitably.
which ore is a mineral from which metal can be extracted. Some of the famous ores, like suppose you have hematite. What is the formula of hematite? Fe2O3. Okay, suppose zinc blend. Zinc blend. What is zinc blend? ZNS. Suppose cinnabar. What is cinnabar? Cinnabar is ore of mercury HGS. Suppose bauxite. What is bauxite formula? Al2O3.2H2O. These are some of the famous ores which we get in the earth crust. From this, we can extract different. There are so many out there. So many ores are there. Ore is a mineral from which metal can be extracted profitably. So three definitions I told. What are the three definitions? Metallurgy, mineral, ore. Okay, metallurgy means steps involved. What are the steps involved? There are four steps involved. I'll explain you now in the next. Okay, mineral is any substance which is extracted from the earth crust is called mineral, and ore is a mineral from which metal can be extracted profitably. It should be profitable. If it's not profitable, also it's waste of extracting. It should be profitable. Okay, so like that, this is the definition of metallurgy, mineral, and ore. Now, what are the steps involved in extraction of metals? I will discuss. See here. So, what are the steps involved in the extraction of metals? We have concentration of the ore, concentration of the ore, concentration. Next, oxidation of the ore, oxidation of the ore. Next, extraction of the metal, extraction of the metal. Next, refining of the metal, refining of the metal. These are the four steps involved in extraction of metals. Concentration is also called as sometimes enrichment. Sometimes this is also called as dressing. Anything is okay, but concentration, oxidation, extraction, refining. COER. Concentration, oxidation, extraction, purification. One by one step, just I will explain. Again, I will explain detail. Concentration means we will remove the impurities, physical impurities which we can see. We will remove the impurities, and the impurities obtained here is called gang. The impurities obtained here is called gang. What is gang? The impurities present in the ore is called gang. What is gang? The impurities present in the ore is called gang. The impurities present in the ore is called gang. Next, oxidation. What is oxidation? We will convert the this we have concentrated the ore. No, that ore we will oxidize. Ore is oxidized. Ore is oxidized. Why use ore is oxidized? Let it be sulfur ore, let it be nitrate ore, let it be carbonate ore, let it be bicarbonate ore, any ore we have to convert into oxide ore. Why will convert into oxide ore? Because removal of oxygen is easy. Instead of removing sulfur, nitrogen, that this, removal of oxygen is easy. Next, extraction. Now we have oxide ore. We converted the ores into oxide. From oxide, you remove oxygen. From oxide, you remove oxygen, you will get the metal. That is called extraction. Now this metal, you have to subject it to refining. That is how metallurgy is done. So those who did not understand, again I'm saying, in concentration, we will remove the impurities. The what are the impurities present in the ore is called gangue. Impurities present in the ore is called what? Gangue. We will remove the impurities. Next step, what we will do, we will convert the ore into oxide. Why only into oxide? Because removal of oxygen is easy. What we'll do, we'll convert any type of ore into oxide. Why? Because oxide ore, if you convert, removal of oxygen is easy. In third step, we'll remove the oxygen, we'll get the metal. That is called extraction. And in fourth step, we'll go for refining of the metal, purifying of the metal, refining of the metal. These are the four steps. Okay. Harika, what are the four steps of metallurgy?
Concentration, oxidation, extraction, and refining.
Concentration, oxidation, extraction, and refining. What is concentration?
The impurities present in ore are removed.
Name removed. Just impurity. What is the impurities present in the ore are called? Gangue.
Gang.
And now in oxidation, what we'll do? We'll convert the ore into.
Oxides.
We'll convert the ore into oxide. Why only oxide?
Removal of oxide is easy.
Oxygen is easy. Removal of
Oxygen
oxygen is
is
easy.
easy.
In third step, what we'll do?
We'll
We'll
remove
remove
the
the oxygen and we'll get the
oxygen.
metal.
Metal.
In fourth step, we'll
Get the
refine the
metal.
metal. We'll refine the metal. Okay,
Refine the
mute
metal.
your audio. Mute your audio.
Yes, sir.
So, so children, so we have studied, first we have studied metallurgy. Metallurgy means steps involved in extraction of ore. Then mineral. Mineral is any substance which is extracted from earth's crust. Then we studied ore. Ore is a mineral from which metal can be extracted. Then I said concentration. Concentration is removal of impurities. In concentration, we'll get impurities. That impurities are called as gangue. Then we'll subject it to oxidation. What is oxidation? We'll convert the ore into oxide. We'll convert the ore into oxide. Why do we convert ore into oxide? Because removal of oxygen is easy. Then after oxidation, we'll go for extraction. Means we'll remove the oxygen. If you remove the oxygen, you'll get the metal. If you remove the oxygen, you'll get the metal. And that metal which you're getting, will subject it to refining. This is how it is done, children. Okay. Now let's go for concentration. First step, concentration. Concentration. What is concentration? Removal of impurities. What is concentration? Removal of impurities. What is concentration? Removal of impurities is called as concentration. Removal of impurities is called as concentration. Okay, so what are the different methods of removal of impurities we have? We have so many different methods of removal of impurities. So some of the famous methods I will say, some of the famous methods, only famous methods. First one is hydraulic washing. Second one is magnetic separation. Third one is froth rotation. And fourth one is Bayer's process. So many different methods are there. So these are some of the famous methods. Hydraulic washing. Hydraulic washing we will do for oxide ores. Hydraulic washing we will do for oxide ores. Magnetic separation we will do for iron ores. Froth rotation we will do for sulfide ores. Bayer's process we will do for aluminium ores. Okay, so in hydraulic washing, what they will do means they will take a sloping thing and small depressions will be there here like this small depressions. Ore is kept here. With a blast of water, it is sent down. With a blast of water, it is sent down. When all the things are going down, all the impurities will be settling down. All the impurities will be settling down. 1 second. So what happens? Ore particles are crushed and kept on a slopy surface. Okay, when they are kept, they are washed with the flow of water. So less density impurities are carried away by water, leaving the more denser particles behind. So here ore is left over, here ore is left over, and all the impurities are washed away. all the impurities are washed away. So hydraulic washing is done for oxide ores. Hydraulic washing is done for oxide ores. Hydraulic washing is done for oxide. Magnetic separation. Here, this is a magnet. Okay, this is a magnet, this is a magnet, this is a magnet. Here iron ore is kept, here iron is kept, here iron ore is kept. So like this, when it is coming, because this is a magnet, iron ore will come and fall here, and all non-magnetic impurities will fall here. This is how we can separate. Because it is iron, iron will attach here and it will come and fall here, whereas non-magnetic impurities will go and fall down. Froth rotation, you will take sulfide ores, we'll take sulfide ores. Into the sulfide ores, we'll add eucalyptus oil. Into the sulfide ore, we'll add eucalyptus oil. And after adding eucalyptus oil, we will send a blast of air. Okay, to the sulfide ore, we'll add eucalyptus oil and we'll send a blast of air. When you send blast of air, all the froth will come up. All the froth will come up. Okay, with this froth, what happens? Froth is separated and washed to get ore. With the froth, ore will come up, leaving behind all impurities. Froth means like what we say, foam. Like in coffee and milk, you will get on the top, no foam. That is froth. So what we'll do? We will take sulfide ore. We will send air. We will take sulfide ore. We will put eucalyptus oil, and we will send a blast of air. All the froth will come up, bringing the ore, and impurities are left behind. These are the different methods of concentration. What is the main aim of concentration? To remove the impurities. So somehow we are removing the impurities. Bayer's process is done for aluminium ores. Bayer's process is done for aluminum. And sometimes hand picking is also there. Hand picking means with hand we will remove the impurities. Hand picking is also there. Hand picking, with hand will remove the impurities. Physical impurities which we can see can be removed. So first step is over concentration. What is meant by concentration? Removal of impurities. What is meant by concentration? Removal of impurities. And the impurities obtained here is called gangue. The impurities obtained here is called gangue. What are the different methods we have? Hand picking, hydraulic washing, froth flotation, magnetic separation, Bayer's process. Different procedures are there. This is concentration. So you remember, concentration is done for only to remove the impurities, external impurities. Now let's go for next step, oxidation. Okay, so Harika, you understood what is concentration?
Concentration is the removal of impurities.
What are the different methods of concentration I told? Hand picking,
Hydrotic washing,
hydraulic,
magnetic separation, froth flotation, and hand
Bayer's
picking,
process,
Bayer's process, and
oh,
hand picking.
hand picking. And next step is oxidation. This ore is converted into oxide. Ore is converted into Harika, ore is converted into oxide.
Oxides.
Why? Removal of oxygen is
Oxides
easy.
is easy.
Removal of oxygen is easy. How to convert into oxides means there are different procedures are there. Some of the famous procedures is calcination is one, roasting is another. Calcination and roasting are two famous methods where we will convert the ores into oxides. Different procedures are there. I'm saying some of the famous procedures: calcination and roasting. What is calcination? Heating the ore in absence of air. Heating ore in absence of air. Heating the ore in absence of air. Roasting means like frying. Roasting means heating ore in presence of air. Heating the ore in presence of air. Heating the ore in presence of air. Calcination, C for C, easy to remember, is done for carbonate ores. Calcination is done for carbonate ores which we get from earth crust. Roasting is done for sulfide ores. Roasting is done for sulfide ores. Name one any carbonate ore, calamine. Zinc carbonate is called calamine ore. On heating in absence of air, you get ZNO plus CO2. CO2 is a gas escapes out, leaving behind ZNO. What is ZNO? Zinc oxide. I told no, we'll convert the ores into oxides.
Yes, sir.
Sulfide ore, zinc blend. Zinc blend, heat in presence of air plus oxygen. You will get ZNO plus SO2. SO2 is gas, leaves behind zinc oxide. Zinc oxide means what? Again, we converted the ore into oxides. Somehow we have to convert all the ores into oxides. Somehow we should convert all the ores into oxides. Why to convert all the ores into oxides? Because in third step, Removal of oxygen is
Easy.
easy. In third step in extraction, just remove the oxygen, you get the metal. That's all. So children, first step is over, second step is over. Now third step will go. What is third step? What is third step? Extraction. In extraction, what we will do in extraction? From oxide ore, remove oxygen. What are the metals? For some of the famous metals we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver. Some of the famous metals. Can you tell their oxides names? Potassium oxide name. Harika, what is potassium oxide?
Um,
K2O.
K2O, Na2O, CO2, CO, MgO, Al2O3, ZNO, Fe2O3, PbO,
This one is.
HCO, HgO.
All the oxides are there in the step. We have oxides. What we have? Oxides. We have converted all the ores into oxides in second step. Whatever may be the salt, whatever may be the ore, will convert into oxide. What is our aim in third step, Harika? What is our aim in third step?
Removal of oxygen.
How do you remove oxygen? For down metals, just to go for direct heating because they are least reactive, they will lose oxygen very easily. For middle metals, heat them in presence of oxidizing agents like some coke or something, anything. And for the upper metals, because they are highly reactive, go for electrolysis. Because they are highly reactive, they don't lose their oxygen that much easily. Until and unless you pass the current and subject it to electrolysis, they won't lose their oxygen because they are highly reactive. So for the down metals, just heating is enough. Why? Because they are least reactive. For the middle metals, heat in presence of reducing agent like coke, and for upper metals, go for electrolysis. Middle metals upper metals electrolysis. Middle metals heat in presence of any reducing agent which can remove oxygen, and for down metals go for direct heating. Okay, so down metals direct heating means suppose CuO is there. If you heat it, you will directly get Cu plus O2. O2 is a gas, it goes away, leaving behind copper. Suppose mercury oxide is there, HgO. If you heat it, you'll get mercury plus oxygen. Oxygen goes away, leaving behind metal. Our aim is to get the metal only, no? We got it off. And the middle metals, like suppose zinc oxide is there. Zinc oxide, directly if you heat it, won't leave oxygen because it is a little bit more active. So put some carbon. Carbon will take this oxygen and forms carbon monoxide, leaving behind zinc. Zinc you got. Suppose Fe2O3, hematite is there, put carbon, you'll get Fe plus CO2, iron we got. Suppose Al2O3 is there, put carbon, you'll get Al plus CO2 over. If you want metal, put some reducing agents. What are reducing agents? Put some reducing agents, means which will reduce the other metals. Okay, which will reduce the other metals. Take some reducing agents like coke. Okay, heat and presence of reducing agents. Heat in presence of reducing agent. This will reduce the other metal. What is reduce? What is reduce? Reduce means it will remove the oxygen. Okay, and upper metals go for electrolysis.
Electrolysis.
What is meant by electrolysis? Pass the current. What is meant by electrolysis? Pass the current. Okay, when you pass the
Iron.
current, see here, suppose potassium oxide is there. When you pass the current, it breaks up into K plus O minus. Because this is minus, where it will go? It will go to anode. After going to anode, what it will do? It will give you two extra electrons which is it having and converts into oxygen gas and escapes away into the atmosphere. Now, potassium, where it will go? It will go to cathode. At cathode, K plus 1 is there. It is in need of one electron. Okay, one electron it will take from here and it will become potassium metal. Simple. That's it. No, sir, I didn't understand this. One more. Suppose calcium oxide is there. Pass current. It breaks up into Ca plus 2, O minus 2. Okay, O minus 2 goes to anode and gives two electrons and becomes oxygen gas. Okay, And to cathode, who will go Ca plus 2. After going Ca plus 2 there, if you take these two electrons and forms calcium metal, that's it, simple. Suppose you didn't understand one more. Suppose Al2O3 cell pass the current. If you pass the current, what you get? Al plus 3 and O minus 2. Okay, O minus 2 where it will go? Anode. After going to anode, what O minus 2 will give? It will give its two electrons and forms oxygen gas. Who will go to cathode? Aluminium plus 3. It's in need of 3 electrons. Two, okay, so 3 electrons means on balancing you will get 3 electrons you will take and it will form Al plus 3. Al plus 3 will take the 3 electrons from forms aluminium metal. So down metals, just by heating you will get the metal. Middle metals you have to heat in presence of reducing agents like coke. And for the upper metals, if you do electrolysis, our main intention is to get the metal. You got the metal over. Take that metal and go for the last step refining. Take that metal and go for the last step refining of the metal. Take that metal and go for the last step refining of the metal. Refining is done in different methods. Some people do it for distillation, some people will do it with liquefaction, and even electrolytic refining is there. Famous is electrolytic refining. I will tell electrolytic refining. Even distillation and liquefaction I will say later. First, listen electrolytic refining. So now suppose you have impure copper. Harika, are you able to understand?
Yes, sir, I'm able to.
In first step we removed impurities.
Yes, sir.
In second step we converted the ore into oxide.
Oxides.
In third step we removed.
Oxygen.
Now we have metal, impure metal. That we
Yes,
have to
sir.
purify.
Yes, sir.
Take impure metal here, impure copper, and connect it to anode. Okay, why anode sir means I will tell. And this is impure. Take already existing pure copper, connecting it cathode. So it is cathode. Connect to negative terminal, it is cathode. And here we will take some electrolyte. What electrolyte we will take? Some copper salt like copper sulfate or copper nitrate or copper phosphate. Something copper salt only you should take. If you are purifying copper, take copper salt only. Here impure, here pure. On passing current, the metal ions, pure metal ions, copper plus means it will always go to cathode, no? Plus means it will always goes to cathode, no? That's why cathode I took pure one. So all the pure copper ions from here will go and settle here. And even from the electrolyte, pure copper ions will go and settle here, leaving behind all impurities here called as anode mud. Suppose you didn't understand one more, I will say. Suppose you want to purify silver. Impure silver, take it as anode. Impure silver. Pure silver already existing, take it as cathode. And some take silver salt. Some silver salt only. When I'm purifying silver, I should take silver salt only. I can't take some other salt, copper salt. Okay. So on passing current, pure silver from impurities will go and settle here. And even pure silver from electrolyte will go and settle here. Why they are going to cathode? Because metals are always positive ions. Metals always form positive ions. Positive will go to negative only. Metals always form positive ions. How they form positive ions? By giving electrons. Metals always give electrons and form positive ions, cations. Cations will go to cathode only. Again, I am saying metals always give electrons and form positive ions. Positive ions means cations. Cations always goes to cathode. That's why cathode I am putting pure one. On pure one, pure thing is settling. Nothing will happen. Suppose you didn't understand last time saying. Suppose you want to purify zinc. Take impure zinc at anode. Take already existing pure zinc at cathode. And electrolyte is some zinc salt like zinc chloride, zinc nitrate, etc. Pass current. Pure zinc from here will go and settle here. And pure zinc from electrolyte also comes and settle here. And you will get pure. If you take 5 kg zinc, at the end of reaction, you get 10 kg zinc. Like this, these are the different steps we are doing for the purification. So, just I will tell from the beginning in summary, like I will see. First, I told metallurgy. What is metallurgy? Steps involved in extraction of metal. That is very simple. What is mineral? Any substance which you extract from earth crust is called mineral. What is ore? It is a mineral from which metal can be extracted profitably. Next, concentration. Concentration means removal of impurities, just removal of impurities, and impurities are called as gang. And what are the methods we studied? Hand picking, hydraulic washing, froth flotation, Bayer's process, magnetic separation. Next, oxidation. What we will do in oxidation? We will convert the ores into oxide.
Oxides.
Why we will convert ores into oxides? Because removal of oxygen is easy.
Easy.
Two methods I told here: calcination, roasting. Calcination is heating in absence of air. Roasting is heating in presence of air. Heating the ore in presence of air is called roasting. Roasting is done for sulfide ores. Calcination is done for carbonate ores. Next, extraction. In extraction, how do you go for down metals? For down metals, how do you extract? Just by heating, direct heat.
Heating. Direct heat.
How do you go for middle metals? Heating in presence of
Heating. Reducing agents.
like coke. And for the upper metals, how you will go?
Electrolysis.
Electrolysis. Why electrolysis? Because they are more reactive.
More
Then we'll
electric.
go for refining of the metal. In refining of the metal, three things you have to remember: what is anode, what is cathode, what is electrolyte. What is the anode we are taking in refining? Impure metal we are taking as anode. What is cathode you are taking? Already existing pure one. And what is the electrolyte? Salt of the metal to be purified. Suppose if I want to purify copper, impure copper I will take as anode, pure copper I will take as cathode, some copper salt I will take as electrolyte. Suppose I want to purify silver. Impure silver, I will take it as anode. Pure silver, I will take it as cathode. Some silver salt, I will take as electrolyte. Suppose I want to purify zinc. Impure zinc, I will take as anode. Pure zinc, I will take as cathode. Some zinc salt, I will take as electrolyte. Suppose I want to purify tin. Harika. Impure tin, I will take as anode.
Anode.
Pure tin, I will
Pure
take it
tin.
as,
Cathode.
and tin salt I will take
Tin
it as
salt. Electrolyte.
electrolyte. So this is how all the metallurgy is happening, and some procedures like small smelting, roasting, okay, and what is pouring, and how blast furnace is extracted. In blast furnace, how to extract the metals, all those things I'll say in the next class, and I will complete the lesson. So this is how the lesson, this lesson metallurgy is explained. Did you understand? And anyone have